Alright, okay. Let's talk about reciprocal graphs. Alright, this is what you call a reciprocal graph. Okay, you need to know the general shape of these kinds of graphs. Okay, so you've got a linear graph, a straight line, quadratic graph, the parabola, U shape or N shape, and in my previous video I talked to you about cubic graphs. Okay, these are reciprocal graphs, and a reciprocal graph generally looks like that. You've got two branches on opposite sides of the quadrants here. Okay, one branch looks like this, one branch looks like this, and you don't connect the two. Why do they look like this? Okay, well, here's your general equation of a reciprocal graph: y equals 1 over x. Do you remember what the term reciprocal means? Reciprocal in layman's terms means you turn the fraction upside down. Okay, so if the reciprocal of 1 is 1, reciprocal of 2 is a half, 3 is a third, 4 is a quarter, 5 is a fifth. Okay, remember the number 1 you can write as 1 over 1, the number 2 is 2 over 1, 3 is 3 over 1. Okay, you can write any integer as a fraction as numerator and then divide by 1. Okay, and similarly the reciprocal of a fifth is 5, a quarter is 4, and the third is 3, half is 2, and so on. Why does it look like this? Okay, well, look, let's talk about these values here. For the x coordinates 1, 2, 3, 4, 5, the y coordinates are getting smaller and smaller, aren't they? 1, half, third, quarter, fifth. So if we just begin there, say at the point 1, 1, after that, as the x values get larger, the y values are getting smaller. Okay. However, you'll never be able to have a value of y is 0. Why won't you have a value of y is 0? Because the 1 on the top there means you cannot divide that by any number in order to get you 0. Does that make sense? Let me say it another way. When you've got 1 over x, you cannot have x be any number that will give you 0. You can get very close to 0, okay? So you can get, say, 10,000, or 10 million, or 100 million, or a billion, or a trillion, tens of thousands, 1,000. Google, okay? No matter how high a number you get, you'll never get to 0, okay? Because you just have 1 over that value, okay? So just put a generic 10,000 in to show you get a very small value. So you get infinitely large values of x, but then we say infinitely small values of y. Okay, so because y will never be 0, the curve gets closer and closer to it, but never actually touches it. You can extend your x-axis infinitely in that direction, and the curve is just going to get closer and closer and closer to it. Okay, it'll never actually touch it. We say that the x-axis is an asymptote. That is a crucial mathematical term that you should know and that you need to know and you should learn it. Okay, asymptote. Okay, when the curve gets closer and closer to that particular line, in this case the x-axis, but never actually touches it. All right. Let's see what's happening when x gets smaller. Okay, so look, I've got the values of fifth, quarter, third, half, 1. You can see as x gets smaller, okay, the values of y get bigger. Okay, so as x gets smaller after this point, so you got x is like half, third, quarter, fifth, and so on. Y gets larger. Okay, so for example, if I just took this the other way around, if I have a very small value of x, say 1 over 10,000 this time, the reciprocal of that will be 10,000. If I had 1 over a million, the reciprocal will be a million. So a very, very small value of x gives you a very, very large value of y. Okay, but x can never be 0 because we can't do 1 divided by 0, an undefined value. Your calculator will not enjoy it very much if you try to do 1 divided by 0. It'll say math error or something like that. Okay. We call the y-axis an asymptote as well. Okay. The y-axis is an asymptote. An asymptote shows us a value of either x or y that is undefined, and the word undefined is used quite a lot, particularly at this level of mathematics and beyond. Okay, so this will not work for x equals 0. If we say x is 0 is undefined for this, and y is 0 is undefined as well. Okay, in order to write this as a function, we have to specify x is not equal to 0, y is not equal to 0 either. Okay, and so you get this branch, okay, this curved branch happening. It approaches this x-axis and approaches that y-axis there. Okay, so that explains why the shape looks like that. And then you've got exactly the same thing going on over here in the bottom left quadrant. Why is it exactly the same? Well, if we make all these x values negative, okay? Then because you're just doing 1 divided by those x values, the y values are the same but negative, okay? And the same with all these, okay? If all those x values are negative, then the y values are all going to be exactly the same but negative. Remember you saw that with the cubic function, okay? Y equals x cubed. The y values are the same but negative for the x values, if you just multiply x values by a -1. And so when that happens, you get a rotational symmetry effect on the graph, okay? So that is, this branch here can be rotated 180 degrees about the origin onto this branch here, okay? And so, yeah, that's a reciprocal graph. It's basically in this quadrant and this quadrant there, all right? That's the very basic shape. What happens if you want to draw a graph like y equals 2 over x? Well, the 2 just makes everything steeper a little bit, okay? So you have the same x values, but just double the y values, okay? And when you're just doubling the y coordinates, you just draw the shape so it's steeper, okay? What if you had y equals 10 over x? You just get steeper by a factor of 10. Basically, for the graph y equals a over x, where a is a positive value, okay? The shape of it is always going to be like this, okay? They're quite quick and easy. Can you see why you need to memorise these shapes of the graphs? Because they need to be drawn out that quickly, you see, in an exam. All right. So that's the graph of y equals a over x, where a is any positive value. Okay. What about y equals -1 over x? Okay. Well, when y equals -1 over x, what happens is, let me just rub these bits out. Okay. When you've got a positive value of x, you get the same values of y but negative, okay? So these positive values of x, they'll give you negative values of y, okay? So what will happen is, the graph ends up being in that quadrant there, and in that quadrant there. Let me just rub that out and draw that for you, okay? I'm sure you can imagine it, I know, but I kind of like to draw this out for you as well. Alright, so let's just change that equation to y equals -1 over x, okay? And it just looks like this here, you see. So all these positive x values you see, you get negative y values, okay? And then the reverse will happen. If I make all these x values negative, those values of y will be positive, okay? And so you get exactly the same shaped graph, just in those 2 quadrants there, okay? So quite simply, when you've got y equals a over x, looks like that, okay? And then you've got y equals -a over x, and then it's kind of like this in those quadrants, okay? So, yeah, so I'm just going to flip the board over. There we go. Some people say flip when they're being reciprocal. Please don't do that. It's, you flip the board over, yeah. You flip a coin, yeah, but you don't flip a fraction. You take the reciprocal. Okay. Yeah. So yeah, you just got to remember those 2 shapes. Okay. So they're in the opposing quadrants there and there for the positive reciprocal graph, and there for the negative reciprocal graph. Apart from that, it's just, there's not really much to it, okay? You'll see more maybe in year 13, but for year 12, that's all you need to know for now, okay? Hoping that was helpful to you. I'll see you again.